So we do other types of differentiation, other methods of differentiation. Okay, so we did type 1, method 1, which was first principle. Method 2, power rule. Power rule, if f of x is equal to x power n, its derivative df dx, which you can also write as f prime of x, is going to be, you multiply the power by the whole function except from the power you subtract 1. That will be the derivative. That's what the rule does. So if you look at the example that we had, our part 1 was y is equal to 2x plus 1. So if it was using power rule, would have said, since here the power is 1, you could multiply 1 by the whole 2x. I mean, you could multiply 1. So first you leave the 2 outside and multiply 1 by the whole x. And from that power of x, subtract a 1. Meaning we would get 2 multiplied by 1, x power 0, which is equal to 2 by 1 by 1, which is equal to 2. I haven't talked about 1 because 1, if we were to add 1, this one is like x. This one is like it's x. Whenever there is a constant, it's like you're dealing with x power 0 if it is 1. So when you drop the 0 and subtract a 1 from it, what you will get is just 0. So that there was just 0 and then you get 2. For power.
So I've got a question. So does that only mean when we've got a constant where since the constant is the same as 0, does that only apply to the power rule or even the first principle or all the methods?
All the methods, whenever it's a constant, the derivative will be 0.
But on these previous examples, I don't think we put any 0 anywhere when we're using the first principle.
So the first principle, the 0 came in when we said 3 minus 3. It gave us 0.
Oh, okay.
Yes. So now we go to B. We go to B of question 2 of the tutorial sheet. We do B, question 2B of tutorial sheet 9. Find dy dx of the following. Find dy dx. 1, y is equal to -7 x power 6. So we are saying dy dx by power rule, -7 is there, and then from x power 6 we drop the 6, which is the n, which is the power, and from it we subtract a 1. So we get -7 by 6, that is -42 x power 5. That is dy dx. Part 2, y is equal to 3x power 5 minus 1. Would say dy dx is equal to 3, 5, x 5 minus 1 minus 0, so that you have 15 x power 4. Nothing complicated yet. Y is equal to 13x power 4 minus 6x3 minus x minus 1. We get dy dx to be, so be differentiating each piece. This will be 13 4 x 4 minus 1 minus 6 3 x 3 minus 2 minus 1 minus 1 x 1 minus 1 minus 0. So the constant, I don't write anything. So 13 by 4, we have 1262. Not 60,
I'm very
but
sorry, sir. But why don't we write anything when we have a constant? Why is it equal to 0?
why is it equal to 0?
Yeah.
It's because when it is a constant, we're assuming that, suppose the constant is 7. It's the same that it's being multiplied by x power 0. And so when you keep the 7 aside and drop the power and then subtract 1 from it, you have 7 by 0, which is 0.
Okay, thank you.
Okay. So that, this here and write 0. Okay. So 13 by 4 is 52 x power 3 minus 18 x squared minus 1. So again, you've seen that when the power of x is 1, the x disappears there, you just remain the constant.
Sir,
Huh?
there when you multiply the 6 times 3, the power when you subtract 3 minus 2, is it going to be just x
And
on
where
18?
did even 2 come from? It's supposed to be 1.
Oh.
Yes. Then 4, y is equal to negative 1 over 4 x power 8 plus half x power 4 minus 3x squared. Then you are saying dy dx is going to be negative 1 over 4 multiplied by 8 x power 8 minus 1 plus 1 over 2 by 4 x power 4 minus 1 minus 3 by 2 x 2 minus 1. So we get negative 2 x power 7 plus 2 x power 3 minus 6x. That is our derivative. 5 y is x4 minus 9x squared minus 5x we are told we must differentiate at a point 3,15. That means that dy dx will be evaluated at a point. So for the first one, it will be 4x, 4 minus 1, minus 9, 2, x, 2 minus 1, minus 5, x, 1 minus 1, giving us 4x, 3, minus 18x, minus 5. Evaluating this at a point 3,15, where there is x, we'll put 3, minus 18, 3, minus 5. Ideally, we must get 15. So 27 by 4, 27 by 4, that's 54 by 2, which is 108. 108 minus 18 by 3, that's 4 carried 2, 54, minus 5. So it doesn't make sense because 108 minus 54, that's 54. 54 minus 5, 54 minus 5, that's 49. So to say 3,15 does not make sense. What should make sense is we should evaluate this at x. Should evaluate this at if they want a point, they must say at a point 3,49. Oh yeah. So it's okay. 3,15. So the initial 3,15 is for this, not for the derivative. The derivative gives us the gradient. So the gradient at that point is 49. Okay. So though we don't name them gradients yet, we'll talk about the gradient term later. Okay. Then 6 y is equal to x power 1 over 4 minus 2 over x. First thing, you can write this as x power 1 over 4 minus 2 x power negative 1, so that you have the power, and then dy dx. Let me put it on the right, and then dy dx becomes 1 over 4x, 1 over 4 minus 1, minus 2 minus 1, x negative 1 minus 1, giving us 1 over 4x, negative 3 over 4, plus 2 x negative 2. But because we found the x down, we must take x down. So whichever x has a power negative, it must be taken in the denominator, the positive power. plus 2 over x squared. So that is power rule. Okay. Then so this was method 2. Method 3, product rule. Product rule. In fact, let's start with chain rule. Chain rule, if f of x is a function g of x to the power n, to differentiate f, you get n multiplied by g of x, reduce n as if it's normal power rule. And then because g is a function inside there, we need to multiply this by the derivative of g, like that. Examples. The theory sheet does not provide examples, so we'll have to look for our own. Example 1. So we're saying find dy dx. Example 1. F of x is equal to 3x squared plus x to the power 4. So you say df dx is 4 3x squared plus x 4 minus 1 multiplied by dx of 3x squared plus x, meaning we have 4 3x squared plus x to the power 3 multiplied by, when we differentiate 3x squared, it will give us 3 by 2 multiplied by x plus 1 for x there, so that we get 4 3x squared plus x 3 multiplied by 6x plus 1. In calculus, we don't depend much on simplification and simplifying until you make a mistake. No. Two, if f of x is equal to the root of x7 minus x5, we can write this as you differentiate. So now you're looking for a derivative. You say solution, and you write f of x as x power 7 minus x power 5 to the power half, so that f prime of x becomes half x power 7 minus x5 half minus 1 multiplied by the derivative of the inside 7x power 6 minus 5x power 4. as you differentiate the inside. So you get half x7 minus x5 negative half 7x6 minus 5x4. Like that. Okay, and then another method, method 4. Okay, now talk about product rule. If f of x is equal to u multiplied by v, where u and v are functions of x, then the derivative of f is going to be the derivative of u multiplied by v plus the derivative of v multiplied by u. Examples: find dy dx of 1 f of x. So when I say dy dx of y is equal to 3x4 minus 7 multiplied by 4x3 plus 8x squared, maybe to the power 7. You've seen that these are two things that you can't easily combine. If you try to combine this to have one function, you have to expand all the way up to power 7 and then you come back and expand. So that would be too much work. So you say, let u be 3x4 minus 7. Let v be 4x3 plus 8x squared to the power 7. And then the derivative of u is 12x3 minus 0. The derivative of v is 7, 4x3 plus 8x squared to the power 6 multiplied by the derivative of the inside, which is 12x squared plus 16x. So that dy dx becomes u prime v plus v prime u. U prime 12x3, v 4x3 plus 8x squared power 7 plus v prime 7 4x3 plus 8x squared power 6 multiplied by 12x squared plus 16x. That is v prime multiplied by u, and u is 3x4 minus 7. So this is our solution. Two y.
So I've got a question.
Okay.
On this v prime here, the ones in the brackets here, wait, what am I saying? Okay, so the power rule here is only being used on these other terms which are in the second bracket. Because here, this 3 here is still the same as it is in the equation, and then it's only reduced after we multiplied 4 times 3.
Yes, because that one is coming from chain rule, which says drop the power and keep g as it is, and only affect g when you're differentiating it outside.
Okay. Okay, thank you.
So 2y is equal to 3x squared multiplied by root of x4 minus 1. So again, there's no way we can put those two together. So we just say, okay, our solution will be letting u to be 3x squared and v to be x4 minus 1 to the power half, so that u prime becomes 6x, v prime becomes half x4 minus 1 to the power half minus 1 multiplied by 4x3 minus 0. So we get half multiplied by 4x3 and then x4 minus 1 to the power negative half. So I've deliberately done that because I've seen that I have a simple simplification. 2 into 4, I'll get 2x3 and then x4 minus 1 to the power negative half. So that dy dx will turn out to be u prime v plus v prime u. U prime is 6x multiplied by v, which is the square root of x4 minus 1, plus v prime is 2x3 multiplied by u, which is 3x squared. Then the other piece of v is 1 over the root of x4 minus 1. So I've said 1 over because that half is negative on top, so I can take it down as positive half. And positive half is the same as the square root. So that here we get 6x, the root of x4 minus 1, plus 2 times 3, we get 6, x power 5 over the root of x4 minus 1. And here. So not oversimplification, but where we see simple simplifications, we do them. That was product rule. So that we also do the fifth one, which is quotient rule. Quotient rule, if f of x is given as u over v, where u and v are functions of x, the derivative f prime of x is going to be u prime v minus v prime u over v squared. Let's see what this means. You have to find f prime of x. 1 f of x is equal to x squared plus 1 over 3x 4 minus x3. You've seen that these are fractions, so your solution should be, by letting u to be the numerator, x squared plus 1, differentiate it, you get 2x. Get v to be the denominator, v prime will be 12x power 3 minus 3x squared. So that our f prime of x will be u prime v minus v prime u over v squared. That is, u prime is 2x, v is 3x4 minus x3, minus v prime is 12, x3 minus 3x squared multiplied by u, which is x squared plus 1. Divide everything by v squared, which is 3x4 minus x3 power 2. You leave it there. Example 2, you have f of x is equal to x minus 1 over the root of x plus 3. Again, these are fractions, so you say the solution will be letting u to be x minus 1 differentiated to give us 1, v to be x plus 3 to the power half, and v prime will be half x plus 3 to the power negative half multiplied by the derivative of the inside, which is just 1. This is just giving us 1 over 2 the root of x plus 3. So that f prime of x becomes u prime v minus v prime u over v squared. U prime is 1 multiplied by v, which is the root of, so writing 1 there, just a waste of time. When you're multiplying 1 by anything, just like that, anything, minus v prime multiplied by u, so u is x minus 1 multiplied by 2 x plus 3. Since you're multiplying by 1 over that, so 1 multiplied by x minus 1 is just that. Then we divide everything by v squared. So v squared will just be x plus 3, since the square will be taken away by the square. So this becomes our derivative. No need of simplifying. When you reach there, it's enough. So far, these are the methods of differentiation that are key. The last one being implicit differentiation. This one is where you are unable to solve for the variable that you're looking for. For example, find dy dx 1 y squared x plus 3x plus y is equal to 4. Here we can't easily solve for x. If we can, then there will be so much issues. In fact, we make it more complicated that we should not even try to solve for y. I mean, how do you solve for y in such a case? So what you do is, wherever y is, you differentiate as a function on its own. So you say, for these two, it's a product. So I can let u to be y squared, v to be x. Just differentiating this piece here, I will have u prime will be the derivative of, it will be just 2y. But because we want dy, we want y with respect to x, whenever we differentiate y, we'll be putting a dy dx, showing that y we have differentiated is a function you're looking for. And then for v, we just differentiate it just like that. So for this piece, we have u prime v plus v prime u. So just for that piece, we will say implying that u prime, so u prime is 2y dy dx multiplied by v, and v is x in this case, so I can put v here, plus v prime is 1 multiplied by u, which is y squared. This whole thing is just for this piece here. Then plus differentiate 3x with respect to x, we just get 3, plus differentiate y to the power 3 with respect to y first. So it becomes 3y squared. But we are supposed to differentiate this y with respect to x. So we just say dy dx. Derivative of a constant is 0. The question is asking us to find dy dx. So you say you factor dy dx. So here we remain with 2xy plus, here we remain with 3y squared. And then we take this and that on the other side. So they will go as -3 minus y squared. Divide 2xy plus 3y squared. Divide 2xy plus 3y squared. This implies that our dy dx is equal to -3 minus y squared over 2xy plus 3y squared. That is our derivative. So whenever you are unable to solve for y alone, you can differentiate y as if it's a function as well. And then just make sure that once you differentiate y with respect to itself, you multiply it by dy dx every time. So if 2y power 4 is equal to 1, what you do is you say, okay, this is 4y power 3 dy dx is equal to 0. And then so for dy dx is equal to 0 over 4y3, implying that dy dx is equal to 0. You can see why it's 0, because we have nothing there is multiplying x. So it's like all of them are constants in terms of x. That's why you get 0. For today, this is enough. We've done all the methods of differentiation. What remains now is doing the applications in the next class. So we covered the class we lost yesterday. We can't do more than this in one day. We have a lot of pages to go through, 6 plus the other one in the other section. Put them together. Go through everything here. But in the next class, we'll look at the applications now. Have a good day.
Thank you, same.
Thank you.